Hello, welcome to our film series on how to use 3D printing to bring STEM into the classroom. In these videos, you'll see how educators can use 3D printing exercises to introduce students to STEM careers and technologies. For this exercise, we'll be using the FlashForge Adventurer 3 printer. The Adventurer 3 is a very nice, affordable 3D printer with a good collection of features for its price. For the STEM exercise, we'll be using one of our Learning Blade 3D Maker Quest lessons. In this lesson, students will build a modular bridge from 3D printed pieces and then test the bridge's structural performance. For this project, you'll need a 3D printer and its compatible filament, a straight edge, a ruler, a scale, some heavy weights like bricks, and a testing area wide enough for the bridge to span. You'll also need a printed copy of the worksheet on the final page of the activity instructions. So let's get started. First, you'll need to unpack and set up your 3D printer. Setting up most 3D printers is a straightforward process. Just follow the startup instructions that come with your printer. If you'd like more information, you can find detailed demonstrations of how to set up and load the FlashForge Adventurer 3 printer at the end of this video. To download the 3D lesson files, we'll go online and visit Thingiverse.com. Thingiverse is a website that hosts a massive collection of 3D models and related exercises. To find today's lesson, go to Thingiverse.com and search for Learning Blade in the main search bar. This will show you a page with today's lesson on building a modular bridge. In Thingiverse, you can choose to download all of the lesson files or individual model files within a collection. For our lesson, we'll click the Download All Files button and select a location on our hard drive to save them. Thingiverse packages everything in a zip file, so once it's downloaded, you'll need to right-click on the zip file and extract all of the files. Now you have all the 3D files needed for this exercise. Once your 3D printer is set up and you have the 3D object files, you can begin 3D printing. Most 3D printers can be controlled by different software applications. For this lesson, we'll demonstrate the FLASHPRINT software that's designed for the Adventurer 3 printer. If you would like to watch a demonstration of downloading and installing FLASHPRINT, skip to the detail sections at the end of this video. To print the 3D objects, launch FLASHPRINT and click the Load button at the top of the screen. Select the 3D model files from where they're saved on your hard drive. This activity will require at least 2 print jobs, one for the bridge spans and another for the bridge pins that connect them. FlashPrint will scan the file and may detect issues with the model's surfaces. If so, FlashPrint will ask if you'd like to repair the file. Click the Repair Model button to continue. FlashPrint may also ask if you'd like the objects centered on the print platform. Click Yes to continue. When you can see your objects inside the printer's print area, you're ready to continue. 3D objects with large overhanging sections will need supports to help each layer of the object print properly. The objects in this exercise do not require supports, but other objects you print might. To add supports, you would click the Supports button at the top of the screen. Then in the Support window, you can have FlashPrint automatically generate supports where they're needed. Our object is ready to print, so we'll click the Print button at the top of the screen. Make sure to change the material type to match the filament type for your machine. We'll make sure the supports are disabled. A raft is a base layer of plastic that's printed onto the platform below the 3D object. The raft helps the object stay in place on the print platform as the filament cools. We want a raft, so make sure the raft option is enabled. FlashPrint allows you to print objects by using either custom or predetermined settings. For this object, we'll use one of the default settings. Once you've chosen the 3D printer settings, click OK. FlashPrint will ask you to save the project file, and then it will show you a preview of the printed object. You can move the Preview Layer slider bar up and down to see any layer of the print job. Once you're satisfied that the print job looks like what you want, click the Send G-code button. This will send the printing commands, a type of instructions called G-code, to the printer. Once the printer has all of the commands, it will begin printing. FlashPrint estimates the amount of time a print job will take and displays that estimate in the upper right corner. Different settings will produce different print times, so with experience, you should get a good feel for how long printing objects will take at different settings. Here, you can see a time-lapse example of how the 3D printing process works. The printer will print the objects layer by layer until the print job is done. Once it finishes, the printer will slide the print bed to the front of the machine and begin cooling down. It's a good idea to wait a few minutes after printing to make sure the print bed isn't too hot. You remove the print bed plate by squeezing the release tab at the front of the bed and sliding out the plate. The 3D object can be removed by flexing the print bed plate. You may need a flat spreader to remove smaller objects. Once you have removed the printed objects from the print bed, you can begin assembling the bridge. The spans are designed to link together in small triangles with the bridge pins pushed through the holes in the ends of the spans. You'll need to connect a duplicate set of spans on each side of a pin. You can keep adding pins and spans to make your bridge as long as you want. Once you have constructed your bridge, it's time to test its performance. Set up a testing area with 2 elevated surfaces, like 2 textbooks. Next, measure the mass of the bridge on the scale and the weights you'll be adding during the tests. Now place the bridge across the 2 surfaces and measure the distance between the 2 edges. Also measure the width of the bridge. During the testing, you'll measure how much the bridge sags under different loads. Place the straight edge across the 2 surfaces next to the bridge and measure how far the bridge sags below the straight edge. With no load, the bridge will probably not sag below the straight edge. Now, add weight to the top of the bridge and repeat the measurement. Record the amount the bridge sags under this new load. Repeat this process with additional weights and record the new measurements on the worksheet. Use the worksheet to calculate the stress and strain on the bridge under each testing condition. Then use the grid area to graph how rigid the bridge is under each testing condition. Educators may wish to expand this activity by having students test their bridges to the point of failure by adding more and more weights until the bridge collapses. Students should also alter or create new bridge features in CAD software. The 3D model files included in this activity can be imported into most CAD software and modified to create new types of bridges and other structures. And that's how this activity works. Now you know how easy it is to use the FlashForge's 3D printers to introduce students to STEM careers and technologies. For more examples of how educators can use 3D printing as a STEM teaching tool, check out some of our other lesson videos in this series. If you'd like to learn more about FlashForge's 3D printers, visit our website at flashforge-usa.com. For more information about Learning Blade and our STEM and computer science lessons, visit learningblade.com or email us at info@learningblade.com. Now, if you'd like to see how to set up your 3D printer, install FlashPrint, or work with 3D objects in Tinkercad, keep watching these informative step-by-step videos. Your 3D printer should have included a set of easy-to-follow setup instructions. After unpacking and removing the shipping materials from the printer, plug the included power supply cable into a wall outlet and power on the printer. Once the printer has powered on, select Filament, then Load on the touchscreen menu. The printer will begin heating up the print nozzle. Once the nozzle has heated up, the touchscreen will ask you to load the filament. Remove the filament door on the side of the printer. Make sure your filament has a smooth, cut end that will easily fit into the intake opening. Take the spool of filament and insert the end of the filament into the intake opening marked by the yellow and black arrow. Once the filament has been inserted about an inch, the printer will automatically start reeling in the filament. Place the filament spool on the spindle, making sure the spool can unroll smoothly. Close the printer door. After about 30 seconds, the plastic filament will start pushing out of the printer nozzle. Once this occurs, press OK on the printer touchscreen menu. The printer filament is now loaded. Once your 3D printer is set up and loaded with filament, we advise you to connect the printer to your Wi-Fi network. This will make printing from the FlashPrint software much quicker and easier. You can connect the printer through the touchscreen menu on the front of the printer. Press Tools, then Network, then Wi-Fi. The printer will then scan for available Wi-Fi networks. Use the left and right arrow buttons to find your Wi-Fi network, then press the name of the network you want to use. This will take you to a screen where you can enter your Wi-Fi password. Once you've entered your password, press the check button at the top right of the screen and the printer will connect to the network. Once the printer is connected, a check mark will show to the right of the network name on the screen. You can now press the return arrow button at the bottom of the screen until you return to the main menu. The printer is now connected and ready to print. The printer comes with a copy of FlashPrint, but it's always best to go to the FlashForge website and download the latest version. Just go to flashforge.com and roll over the support option in the main menu. Select Download Center from the drop-down options. This will take you to the latest versions of the FlashForge software. Find the latest version of the FlashPrint software for your operating system and click the Download button for that version. You'll need to select a location to download the software zip file, and once the software has downloaded, right-click on the zip file and extract all of the files. Double-click on the FlashPrint application to launch the FlashPrint setup. Once FlashPrint has finished installing, select the Launch FlashPrint checkbox and click OK. When FlashPrint opens for the first time, it will ask you to select your printer. Choose Adventurer 3 from the menu and click OK. FlashPrint will open up, showing the blank 3D printing plane within the printer's print area. Before you can print, you'll need to connect FlashPrint to your 3D printer. If you've already connected your printer to your Wi-Fi network, you'll choose Print and Connect Machine from the main menu. This shows a pop-up window with the printer's IP address. To find out your printer's current IP address, go to the printer and select Tools, then About from the printer's touchscreen menu. In the About section, press the right arrow button 2 times to see the printer's current IP address for the Wi-Fi network. This is the number you'll need to enter into FlashPrint's Connect Machine pop-up window. Once you've entered the correct IP address, click the Connect button. After FlashPrint has connected to the 3D printer, the printer's status box will appear in the lower right corner of the software. Click Done to close the pop-up window. Now you are ready to print to your 3D printer. To use Tinkercad, you'll first create an account. Once you've created an account, you can get started by clicking the Create New Designs button. This takes you to a blank 3D workplane where you can drag and drop new 3D objects to make your creations. We recommend also dragging a ruler onto the workplane as well. The ruler will help you manipulate objects with better precision. The key to Tinkercad is how easily it allows you to add, modify, and group new shapes together to create complex objects. To get started, drag a new object from the right menu onto the 3D workplane. When you select an object by left-clicking, Tinkercad shows you the object's main parameters. And if you have a ruler on your workplane, it also shows you the measurements of each of the shape's dimensions. You can modify an object by either dragging one of the control points on a selected object or by left-clicking on the measurement of that parameter and entering a new number. Tinkercad also has tools for grouping together multiple shapes into a new object. Press the Shift key and left-click the shapes you want to combine, and then click the Group button at the top right of the workplane. You can ungroup shapes by selecting the object and clicking the Ungroup button. A very powerful feature of Tinkercad is the ability to turn any shape or object into a whole or negative version of the shape. This means that instead of adding to a shape, a whole or negative object will subtract from a shape once it's included in a group. You can see this in action by selecting a shape and clicking the Whole option in the upper right menu. Now, if you group this whole shape with another shape, the whole shape will be subtracted from the other shape, creating a complex new object. This is how all of our 3D Maker Quest objects were created. And Tinkercad has many other exciting features students may wish to explore. You can import 3D models like STL files to use in your creations. You can change the color of objects. You can mirror an object in a specific direction. You can align objects to an edge or to the center of all the selected objects, and you can also rotate an object in any direction. By experimenting and playing around with Tinkercad, your students can explore the exciting world of creating 3D objects.